Okay, so in this video we're going to look a little bit more at the algorithm for completing the square. So an algorithm is just a series of steps that we take to solve a problem. So what we need to do in this problem is we need to factorize x squared plus 6x take away 5. Now this is the same problem as the previous video, but I'm going to show you how I'd set up the steps for completing the square. So the first thing that I would do is step 1, I would halve the coefficient of x. Now that's this term here. So if I halve that value, half of 6 is 3. Okay, step 2, I would square this value. So if I square 3, I end up with 9. Step 3, I need to add and subtract this value from the expression. So what I already had was the x squared plus 6x, and now I am going to add 9 and subtract it again. Essentially, we've just added 0 onto the expression before putting my minus 5 back at the very end. By doing this, what I achieve is those first 3 terms there can always be factorized. So step 4, factorize the first 3 terms. And it will look like this. I want 2 numbers that multiply to equal 9 and the same 2 numbers that add to get 6. Now that will end up being x plus 3 and x plus 3. I still have a minus 9 on the end. I still have a minus 5 on the end. Alright, step 5. Simplify. Right, so we've got a bit going on in this expression now. So if I want to simplify, those first 2 brackets can become the one bracket with squared because it's just timesing it by itself. And minus 9 subtract 5 is minus 14. Now if you end up in this position where I have the difference of 2 squares, then I can go one step further and I can factorize using dots. And that looks like this. I end up with 2 brackets, one with a plus, one with a minus, and I need the square root of the first term in the first spot. So the square root of x plus 3 all squared is just x plus 3. And I need the square root of the second term in the second spot. Square root of 14 is the square root of 14. And that's fully factorized. So let's see that again now with a different problem that we haven't already done. Let's try this expression, and I won't write all of the steps, I'll just follow the steps along. So let's try factorizing x squared plus 8x minus 1. Alright, so step 1, I need to halve the coefficient of x, and that's negative 4, and then I need to square this term, which is positive 16. Now I'm going to add that 16 to my expression and subtract it at the same time. And I don't know why I put negative 4 there, it should be positive 4. Okay, so now in my expression, the first 3 terms will always be factorized. I want 2 numbers that multiply to equal 16 and add to give 8. And those 2 numbers will always be whatever I wrote down here. So I can shortcut and just write that down. Be x plus 4 all squared. Take away 16, take away 1, which is x plus 4, take away 17. Now in here, at this point here, the step that I skipped was that looking for two factors, x plus 4, x plus 4. I don't need to write that down. I can jump straight to the square version here. Okay, so now I have my expression. It is in turning point form, which can help me with the graphing, but I can also factorize this further by using the difference of two squares. And for the difference of two squares, I have two brackets, one with a plus, one with a minus, and I take the square root of the first part to go in the first part of the bracket and the square root of the second part at the end. So this is what I'm calling the first part, this is what I'm calling the second part. Right, let's try another problem now, and we'll try and confuse you a little bit. Let's put some negatives in there, and let's also bring in some fractions. So how about we try and factorize x squared minus 5x minus 2. So to go through our steps, we start by halving the middle term. Now half of negative 5 is negative 2.5, or negative 5 divided by 2. Then I square that term. Now when I square a negative, I get a positive. 5 squared is 25, 2 squared is 4. Now I need to add and subtract that value from my expression, which looks like this. And the first three terms will always factorize, and whatever is here will be the value that goes inside that bracket. So it will be x take away 5 on 2 squared. So that's the first three terms, and then I've got minus 25 on 4 take away 2. So that's a nice little trick, that this value always ends up in here. And basically we've manipulated how we've done the problem so that that happens. That's what the algorithm is about. This is the series of steps that makes it work. So now I've just got to simplify that end expression, and I am adding fractions. So to add fractions, I need to get a common denominator. And then once I have my common denominator, I can put together those numerators, which becomes 33 over 4. And I now have turning point form. If I want to go further, I can do DOPS, difference of perfect squares. So I have two brackets, one with a plus, one with a minus. The first part, or the first term, goes in front of each of those symbols, and then the square root of the second one goes after it. And I can actually go a step further here, because I can take the square root of 4, which makes root 33 over 2. And because I have a common denominator for those next parts, I could actually write it like this if it makes it a little bit easier. So minus, how am I going to do this? I'm going to make it plus negative 5 plus root 33 over 2. And then x minus 5 plus root 33 over 2. Now that's a little bit tricky. If you can follow what I've done, awesome. If you can't on that very last step, don't stress too much at this point in time. Okay.